Okay. So let's start. I'm Boray, by the way. Let's start with the slides. Yeah, ENS is over on Mina. So let's start with learning the jargon that we will see in the presentation. So CCIP is the core part of this project. It's cross-chain interoperability protocol. It's basically a way to enable cross-chain communication. I will.
Right, we can see the slides now.
Oh, sorry,
Yeah.
1 minute.
I mean, we see your screen, but I don't see your slides.
Okay. Is it okay right now? Can you see the slides?
Yes.
Do you see right now as well?
We see like a screen just says.
Okay.
But I think you can present it like this. Yeah. Right now we see.
Okay. Okay. This is better. So yeah, the CCIP is a way. It enables cross-chain communication, which I will detail in a minute. So domain is basically, we know what domains are from Web 2. In the ENS context, there are like google.com basically points as a string, google.com, to the IP address. So internet users don't have to type IP address every time that they want to enter Google. So a subdomain is basically you can create a subdomain if you have a domain, and you can point it to another resource, another IP address, or in this context, another blockchain address. Also, domains are a tree. So this is basically a node of this subtree, basically, this domain tree. So resolution is basically the process where the domains, the resource that the domain points is gathered. Resolver is the entity that stores this mapping from the strings to the resources. It's maybe IP addresses or blockchain addresses. ENS, Ethereum Name Service, is a project basically brings DNS, domain name service, to Ethereum. So it is distributed and decentralized. Also, it points to blockchain addresses instead of IP addresses, as well as also they can point another things as well. But here I simplified with blockchain addresses. So CCIP is the core part of this project. It is proposed by Nick Johnson from ENS. He's founder of ENS as an EIP, Ethereum Improvement Protocol. So it is also chaining is built on building a CCIP network for cross-chain operability. So it says very simple way to interact with off-chain or off-chain resources or another chains. So basically, in this diagram, there is three entities: a contract in Ethereum layer 1, a gateway, a CCIP gateway, and a client. Here, basically, client calls a function on the Ethereum contract with some data. In our contract context, it's the domain. Then the contract reverts with an call data that basically contains domain data and gateway URL. Then client makes an HTTP request with that call data to the gateway. Then basically gives the response to the contract. Then contract has a logic. Ideally, it has a logic that verifies that result, and contract gives back the result. So with this, basically, we can do a lot of things. So basically, there is trust, as you can see. Gateway is a server, and it is trusted. So Chainlink is building a network of these gateways to distribute that trust, and basically enable cross-chain messaging on this network. But yeah, so removing the trust gateway. So in our context, basically ENS in this context, we want to verify the resolution, the domain resolution on Ethereum. So how we will do that? We need to have first of all, we need to have a Mina state root on Ethereum. Like like just like 22 kilobytes Mina nodes. If we have the Mina state root and the hash of the particular Mina state and a worker proof, we can verify that resolution. So right now, Lambda class is building the Ethereum bridge, and they will post Mina state to Ethereum regularly, but it's still not live. And this is the ideal solution, by the way, because it's cryptographically secure. If like only trust assumption here is the bridge. If bridge posts the correct state root, they also depend on cryptography, not as far as I know, they don't have an economic part. So yeah, if the state root is a wallet, so we can verify the resolution. But right now we don't have it. So right now we have in this repository, in the project's repository, we only have a trusted gateway, but we can have we can use Chainlink CCIP network as a temporary solution. But as I said, it's not optimal because we could have cryptographic security, which is better and which also aligns better with Mina. So yeah, this project is basically a resolver on Mina, just like ENS resolvers on Ethereum. This is on Mina. It has a smart contract, and it has a mapping of domains and Ethereum addresses, not Mina, by the way. So also these are free. So yeah, you can register your .mina.eth subdomain for free. And yeah, these domains are resolved from Mina via the CCIP gateway, and they work just like a subdomain, normal subdomain registered on Ethereum. They work same. Yeah, how it works. So basically, this diagram is very similar to that because it is the same architecture. So yeah, in this context, in this project context, we have also Mina. So yeah, the actor's clients, same thing. Actor sends actor calls the Ethereum contract with the domain, and domain Ethereum contract returns the gateway URL. Then the actor calls the gateway with the domain. Then gateway queries the Mina state, and then returns it back to the actor. Then actor sends this result to the Ethereum and verifies it, and it takes back the address. So domain is resolved. In basically, this actor can be MetaMask or any other wallet. MetaMask has implemented zkIP, so there is no extra logic that should be implemented. It works right now. Yeah, but why? So there is two main motivations behind this project. One is to onboard Ethereum users to Mina. We will give free ENS subdomains, and they will just work just like ENS subdomains. There will not be any difference. I think that's a compelling thing. I will want that. I will want to have a subdomain. So to get this free subdomain, the user must install a Mina wallet and interact with the Mina. Yeah, basically this is promotion, and this will bring Ethereum users, and they will interact and learn Mina. Yeah, they will be exposed to Mina. Then the second motivation is this is basically a public demo of how Mina could be used with Ethereum and with zkIP. Basically, there is like tons of use cases that can be implemented. Like simple one is we can have a DAO on Ethereum, but it's very costly to do private votings on Ethereum because it's very costly to verify snarks. So we can do it on Ethereum Mina, and then when it's ended, and we can relay the result to Ethereum with zkIP, or we can maybe bet on Ethereum on let's say chess. Then we play the chess on Mina, then relay the result to Ethereum, and who who win the player who win will could transfer the stake to himself. Yeah, there's two major problems. One is removing trust, as I mentioned before, as I talked before. The other one is storing the mapping. So in Mina, it is not very easy to store mapping and having data types like mappings and arrays. So we can have we can have them with Merkle trees, but there is a problem. Since let's say you have a Merkle tree, and if one leaf changes, the Merkle root changes, and when two users try to register a subdomain at the same time in the same block, they can't, because when one state transition is approved, the other one will be invalid. So there is a concurrency issue. Therefore, it's very constrained in Mina layer one with the current approach. So ProtoKit solves that, you may say, but I had questions about ProtoKit. First one is how composable ProtoKit app chains are. Matej is probably here. He may answer it at the end of the presentation. I will be happy. Question two is will users really onboarded to Mina? Because like will they have to create an Mina account and pay 1 Mina? And is an app chain really needed to store only one mapping? Yeah, also I am looking for new storage methods. Right now, Gregor is working on a way to store key value pairs using actions, then reducing them and doing the state transition afterwards. Also, I am looking for novel Merkle trees where we can eliminate the concurrency. Yeah. So the GitHub repository is basically like this. the contracts file as SM contracts, and gateway is like, as I said, gateway. So you may see here we have protokit and a zk app folder. So basically, I have these questions, and I couldn't decide which one to build, so I built both. This one is built only with O1.js and works on layer 1, but it has concurrency issue. This one is a protected app chain. It works very well. Yeah. So we may go over the logic a bit. This resolved logic. It's very simple. I used O1.js Merkle and sparse Merkle trees instead of normal Merkle trees because I had to prove non-inclusion as well. Yeah, basically I store named names in this class, in name data class. Then, yeah, this is the commitment for the empty sparse Merkle tree. I have two methods, one for registering and one for updating subdomains. Basically, it checks the sparse Merkle tree that this name doesn't exist on it. Then, if true, it adds that leaf. Then updates the commitments, and the updates set subdomain method works just like it, but it's checks membership instead of non-membership, because if you don't have it, you shouldn't be able to update it. Yeah, the logic is very similar. Yeah. Do you have any questions?
Mert raised.
Max?
So regarding your questions, so I think that I'm just realizing that like a lot of people have the same exact problems. The solution we came up with is that how Cloudflare services are becoming just like AWS, actually even probably more popular. You can just deploy any service with JavaScript, a few lines of code. So the service we have designed for our nodes is actually very generic. I mean, you can, like, if you emit the right events, you can, for your Merkle tree, you can just use our service. You just add 2 emit events, and now you can use our service to get your witnesses in a distributed way, in a trustless way, right? So we are thinking of making it like, I mean, it is open source, but we are thinking of packaging it in a separate thing so anyone can deploy and use it. Oh, it's already done. I see.
Yeah, that's very interesting. I think Gregor builds a very similar thing, just like that, but he uses actions.
I think that one is like fetching the events from a node. Like the service, a witness is a logarithmic in the number of nodes, right? Like you may have like millions of entries in your Merkle tree for subdomains, and the witness will still be like tiny. But the Greg solution will be like downloading million nodes and constructing locally the Merkle tree. That's not going to scale well, but you can rely on a service like that. And the second thing, the sparse trees, like we also consider, I don't know how exactly it is implemented, but we also considered like Merkle BSDs, binary search trees. We implemented them, but then just hashing and using normal trees was way faster, and does the same thing in a randomized way, right? Like as long as there are no collisions. So we can also maybe discuss offline about that. Like I mentioned about how we truncate to the last 32 bits. It's actually like hashing down to a smaller domain and then using normal Merkle tree instead of sparse Merkle tree. Maybe, I don't know how it's implemented. So Matei is saying that you still have race conditions. Yes. So in our way, K-pass, like 1 K-pass per 3 minutes. But the K-pass is you mint it once, use it like forever, but like for other applications, yes, I agree. So Matei is so I'll let him join.
Yeah, I just wanted to say like what you can do is like you can just use Protokit, store your K-passes there, and it's gonna do everything that you were talking about. Like it's gonna allow you to fetch witnesses for it. It's gonna allow you to sequence the transactions and process the 3 operations on chain. So you can do a hybrid execution model thanks to the fact that you can fetch the witnesses to the app chain state tree and stuff like that.
Right.
With your solutions, you would have to rebuild everything that we've already done for the sequencer for it to become viable.
So the thing is that we may launch on L2, but right now, like if you notice, our whole thing is assuming a person who does not have a Mina wallet, who doesn't have a funded Mina wallet, and then get them on board on Mina. So what, like, if a lot of people had like funded Mina wallets, then we may think of L2. But at this moment, I think the point, like the focus should be on onboarding. That's why we're focusing on L1s. And once it's done, yes, we will probably deploy on an L2.
I mean, the thing is that if you don't have a funded wallet and you want to get a Kimlik DAO pass, right, you won't be able to interact with DL1 at all. If you build an L2, you can make the transactions free for the onboarding. And that way you can get rid of this entry barrier.
Okay, we can take it offline, but yeah, the thing is that we are like this whole article is about getting people to fund their wallets and interacting with their first ZK app, and then they will actually end up earning money. So this is an incentive for people to do that. Like if Mina ZK apps are going to come into mainstream use, which I think so, I think this is how it's going to happen. Like,
yeah, but all the ZK apps that are going to be useful in terms of throughput are going to be L2s. Since you take the state Merkle tree, then unless you build an L2, you have a race condition problem.
yeah, we will come to L2s, but not at this stage. I think the right thing is to first get people on L1 and then to L2.
Yeah, actually, I had questions to you, Matesh, right here. So I had 3 questions. This third one is actually what Mark told just before. So my third question was: is an app chain really needed for a very simple app, for simple ZK app? And the second question, if we onboard users to a protected app chain, will they be really onboarded to Mina? Because if they use an ZK app, they should fund their wallet and spend basically pay 1 Mina fee, and they can use another ZK apps without changing chains. And the first question is how composable protected app chains are.
So one by one. So the composability currently can be done through the L1. We have a messaging architecture, allows you to pass messages freely between L1 and the L2 in both directions. I'm not sure what being onboarded to Mina means. Does it mean having an account in the L1 ledger? If yes, what's the point? Like, why is this so important? I don't really understand. You can just onboard the users to the L2, and then when they will want to, they can bridge themselves back to the L1 to do whatever else they might want to do in terms of interoperability. If an app chain is really needed, as I've said before, like as soon as you move your state to a Merkle tree, you are building an app chain. If you want to do it with smart contracts, if you want to deal with your own Merkle tree storage, if you want to deal with your own recursive circuits, you can write all of this by hand. It's going to take you months to complete it, and to achieve the same developer experience that you would have with Burkit like from day one. And all you have to do is just do npm install. So yeah, the reason why we built Burkit wasn't, I mean, just for fun or anything. It was out of necessity. The things that we allow developers to do and the speed that we allow to develop them at simply wasn't possible because the tools didn't exist before we started building them.
I have two follow-up questions. So one is, you said you have an cross-chain messaging protocol or something like that. So is it dependent on app chain finalities? And yeah.
Yeah, that's a good question. So ideally, yes, since reorgs can happen, and if you process messages that have been reorged, then you would have to reorg the L2 as well, which wouldn't be ideal, of course.
My second question is, so protected app chains have sequencers. So how the security of sequencers are ensured because they can censor transactions.
Yeah, you can, but not if users send them as own actions, right? So you're basically making a trade-off between throughput and censorship resistance. Users that are interested or worried about censorship resistance might dispatch transactions to your app chain through L1 actions, and they can still be censored by the person who is producing the block, of course. But you have the whole consensus to deal with that. If they send transactions to the sequencer directly, to the private mempool of the sequencer, of course, they can be censored as well.
Do you have any plans to have a shared sequencer for protected app chains, or every protected app chain will have its own sequencer in future?
So, I mean, having a shared sequencer is one thing. The thing that shared sequencers do, they take a look at a series of independent chains or app chains and help them determine which transactions to build in what order. Our sequencer does not only do sequencing in terms of determining the order of the bundle or the contents of the block, but it also handles all of the execution that comes with it. That is, I would say, way more complicated than just deciding on the order of transactions in a shared sequencer. We have plans to build a shared sequencer. We've been speccing out one pretty recently. But I would say like 80% of the difficult part is actually running the execution of the transactions. That is what the sequencer does as well.
Thank you so much.
All right, thanks. Yeah, thanks all. And I know it's been late, but like I appreciate the discussions here. So like last, yes, Nguyen, Palm.
Yes.
Yeah, it's your turn. Let me.
Okay, so I will share my screen now.